All right, so it says write the definitions of the following terms in your own words. And the reason I say do it in your own words is because that's how you know if you really understand what's going on here. I can give you a book definition, and then what that puts on you is just, I got to memorize that, right? But if you really know it, you can explain it to somebody else. So maybe that's a good way to use the study guide, is to go through those words and talk to a friend, a neighbor, a parent, or well-wisher who would be willing to listen, right? So in your own word, what is matter? Matter is everything that has mass and takes up space. It's easier, I think, to talk about that in terms of what isn't matter. Matter is not light or energy or heat, but it's, you know, it's air, it's tables, it's you, that kind of thing. Substances. When I say this, I really should say pure substance. What is a pure substance? It's a substance that's made of just one kind of particle. All right, and that includes elements and compounds. Now, is a compound one kind of particle? Yes, but can that particle be broken up further? It could be, but you have to make it go through a chemical process. So water is a pure substance. It's made of H2O particles. But at the smallest level that you can get down to is H2O. If you wanted to split that apart, you'd have to make it go through something much more difficult. So either atoms or molecules are going to be your one kind of particle. Elements. These are the simplest substance. They can't be broken down. Okay? Their smallest particle is an atom. That's opposed to compounds. Again, they are a pure substance, but their smallest particle is a molecule, and they can only be broken down chemically. All right, so you can't cut it, you can't use a tweezers to pull it apart, you can't boil it, you can't freeze it. It will always be what it is unless you make it go through a reaction, and that's not a simple process. And then finally, you have a mixture. These are multiple substances that are not chemically combined. Salad dressing, concrete, toothpaste, those can be boiled apart, or they can be frozen apart, or picked apart. Any questions on those terms? All right, number two, how can you know whether or not a substance, whether matter is a substance or a mixture? Again, if it's a substance, there are a couple different ways. If it's a pure substance, so is it an element or is it a compound? If its name is on the periodic table, that's an element, all right? And that can't be broken down. If its name is a chemical formula, it can't be broken down. So you can look at the name or chemical formula. That's one way of knowing. You can also know, can you pick it apart? Can you peel the toppings off a pizza? Yes, you can. Can you do that to a compound or mixture? No. Number three, how can you know whether a substance is an element or a compound? If it's an element, again, it's just going to have a symbol. If it's a compound, it will have a formula, which is more than one symbol. So this would be like something like CO2. This would just be C or O. All right, number 4, write the definitions of the following terms in your own words. Physical property. A physical property is something that a substance has, or a characteristic. And if it's a physical property, it's a characteristic that you can observe without changing it. Right? So again, if I look at ice, I can go, oh, that's cold, it's hard, it's solid. I can observe those things and I don't turn it into a new substance. Or, I don't know, a calculator, it's blue, it has buttons. I can measure its mass. That doesn't change what it is. A physical change is something that you can change about it without changing what it is. So this is a change, and when I say change again, that's a verb. So if it ends with an ing, that's probably a change, right? Boiling, freezing, cutting. A change that does not change the substance. Okay, properties are nouns. Person, place, or thing. All right, a chemical property. A chemical property is a characteristic that you can only observe while it's changing into something else. Or while a new substance is made. Right? There are really only 2 that we talked about ever, flammability and reactivity. Those are the only 2 chemical changes. Rusting is an example of the ability to rust is a chemical property. The ability to burn is a chemical property. But can you see burning? Can you see reacting without something new being made? No, you can't. Anytime you see something burning, you know a new substance is being made. Chemical change then would be a process, again, a verb here. The process of turning into something new. All right, any questions here? All right, I'm going to erase that then. All right, next, write down at least 5 physical properties. Again, the answers for this can vary, but things like size, shape, color, height, mass, boiling point, freezing point, density, volume. Those are all measurable or observable things. How do you know if a property is chemical or physical? So if I say boiling, is boiling a physical or a chemical property? The boiling point, I should say. Is boiling point chemical? That is physical. Okay? Because again, if I boil water, is it not water anymore? No, it's still water, right? So how do you know? if you can observe it without changing what it is. Right? I can observe mass. I can put something on a scale. That doesn't change what it is. I can observe the shape of something. That doesn't change what it is. All right, some of these questions kind of keep going with the same stuff I've been talking about. So number 7, what's the difference between a physical property and a physical change? So what's the difference here? They're both physical, and so really what I'm asking about is what's the difference between a property and a change? And like I said before, a property is a noun, a change is a verb. Something's happening here, that's just something that object has. It has height, it has a boiling point, it has a freezing point, it has a density. If I change it, then I am boiling it, or freezing it, or cutting it. Write down 2 chemical properties. I mentioned these already, reactivity and flammability. What's the difference between a physical and a chemical property? Again, I mentioned this already. Physical property, physical can be observed, but no new substance is formed. Chemical property, only observed while changing into something new. And number 10, what is a chemical change? A chemical change is the process of changing into something new. So the chemical property would be that paper is flammable. The chemical change would be that paper is burning. That steel is reactive. The rust is turning into rust. That's a change. That the rusting would be the chemical change. The ability to be rust is a property. All right, any questions here? All right, moving on. Common clues as to whether or not a change is chemical. Production of heat and light. When I burn something, it produces heat and light, okay? And burning is always a chemical change. Bubbles. That's a production of a gas. Color change. A banana turning brown or a leaf turning red. Those are all examples of a chemical change. Do they always mean that it's a chemical change? No. But they are clues. And so you can take that, you got to sometimes take a body of evidence to decide whether or not something new is being produced. Again, heating up an iron rod and it turns red, that's not chemical. It's still iron. It's gonna, when I let it cool down, it's gonna go back to the way it was. The burners on your stove, same thing. They turn red, but then they turn black again. 11 and 12 are really the same question, so I'm skipping 12. Difference between physical and chemical change, again, it's the product. Okay, if it's a new product, that is a chemical change. Physical change, not a new product. It's the same thing it was before. If you cut your hair, the hair that falls on the ground is still technically your hair, I guess, right? It's still hair. It didn't change. Questions? Okay. Difference between chemical property and chemical change. Again, a chemical property is a, I'm just going to say noun and verb here. Chemical property is something has. Okay, chemical change is that thing happening. You see ing, that's a pretty good change, or clue that that's a change, not a property. Conservation of mass basically means mass at the beginning of any type of change is equal to the mass at the end of that change. You can't make new mass, you can't produce new mass. All right, terms in your own words. Solution. A solution is a homogeneous mixture in which one substance dissolves in another. Now, if I say salt is dissolving in water, that I hear that ing and I go, oh, that's a change. Now, is dissolving a physical or a chemical change? It is a physical change. How do I know that that is not a new substance? Because it still tastes like salt. All right, solute. This is what gets dissolved. Solvent. What does the dissolving? Okay. So if I want to make salt water, salt is the solute, solvent is the water. Water dissolves salt. Solvent dissolves solute. Solubility. This is the amount you can dissolve, okay, in 100 grams of water. If something is soluble, that means it can dissolve. Salt can dissolve in water. If something is insoluble, that means it can't dissolve. Salt will not dissolve in oil. And then the last three here, saturated, that means that's the maximum amount that can dissolve. supersaturated. This is where you have extra dissolved, and unsaturated is less than the maximum. Okay, it's kind of like the Goldilocks and the Three Bears. You've got not enough, too much, and just right. And question number 17, what are 3 ways to make a substance dissolve faster? You can heat, add heat, I should say. So if I'm trying to dissolve something and I put it on a burner, it'll make it dissolve faster. I can crush it, make the particles smaller. Rock salt won't dissolve very fast in water, but little granular salt will. And the other thing is, if I stir it, it'll dissolve even faster. Heat, crushing, stirring. All right, any questions? What's that? Okay. And you know, while I'm waiting here, just remember that when you're writing your 1 page of notes, I don't remember what you guys did yesterday or not, but you can have too much stuff written down. You know, you don't have to write down every single thing we've ever talked about. There are some things that you know pretty well. Don't write that down. It's the stuff that you struggle with that is probably where you're making reminders. Or if there's anything that has to be memorized, that would be something to write down. But the rest of it, you know, have some faith in yourself that you do know things. All right. Solubility curves. How does the amount of heat affect the amount of gas that can be dissolved in a liquid? Remember our solubility curves? We've got all those lines that are going like this. And then there are some lines that go like this. Okay? If they're decreasing, that means as you add heat, they become less and less soluble. So heat affects the amount it decreases the amount that can be dissolved. But if you add heat to a solid that you're dissolving, that will increase it. Those are the green lines. Okay, as I get hotter, more and more and more. Okay, give examples of the following solutions. A solid dissolved in a liquid, all right? I know I beat salt water to death, but it just works. Okay, salt water is a solid dissolved in a liquid. A liquid dissolved in a liquid. If I put alcohol, like rubbing alcohol in water, the rubbing alcohol will dissolve. A solid dissolved in a solid, that's an alloy. That would be something like bronze, steel. You take two metals, you heat them up until they're liquids, you stir them around, and then you let it harden. And then that's an alloy. Those particles have, quote unquote, dissolved in one another. A way to think of a solution, it's something that's perfectly mixed together. And then finally, a gas dissolved in a liquid, that would be like pop, right? You got carbon dioxide dissolved in what? In a liquid.
What was the solid dissolved again?
That would be like an alloy. So steel, bronze, brass. All right, what are the differences between homogeneous and heterogeneous mixtures? Kind of the main thing is that a homogeneous mixture, the particles are the smallest. And we're talking like atom size particles here for homogeneous. Perfectly mixed, you can't tell that there's anything in there. It looks just like it's water, right? The other thing is, light goes right through it. That's called the Tyndall effect. Oh, I'm sorry, no. No Tyndall effect. For a heterogeneous mixture, you have larger particles. You can see beams of light. That is the Tyndall effect. And sometimes they're so poorly mixed that you can tell all the different stuff that's in there. Again, think of like Italian salad dressing. You can see all the different stuff. Okay, common solutions. Salt water. I think I already mentioned alloys, air. Those are all solutions. Colloids would be things like jello, fog, smoke. That's good. Suspensions would be like muddy water, chocolate milk, pulpy orange juice. When you look at a suspension, you can tell that there's big chunks of stuff floating in there. Okay? When you look at a colloid, you look at it and you're like, hey, is that a solution? I don't know. It looks the same all the way through. But if you can't see through it perfectly, then it's a colloid. If it looks like water, it's a solution. All right, just a couple more minutes here. The last part of this is on the solubility curve drawings. You're gonna, like I said, you're gonna get 4 of these questions. First one, how much NH4Cl will dissolve at 70 degrees? Here's 70 degrees. Gotta find NH4Cl. That's right here. So 70 degrees, I go up to the line, then I go over. That's 60 grams. Next question, how much would dissolve in 200 grams of water? Okay, if I have twice as much water, I should be able to dissolve twice as much stuff. So that would be 120. 2 times 60 would be 120. Is this solution saturated, unsaturated, or supersaturated? Well, if it's right on that line, it is saturated. You have just the right amount. Okay, KNO3, 100 grams at 60. $60. I'm at 100 grams. I start out saturated, but I cool it down to 10 degrees. Whoops, right here. So that 100 grams I had, now I'm only allowed to have like 23. So the question is that saturated or supersaturated or unsaturated now? Well, I have too much. That's supersaturated. Okay, 28. Is CeSO2 a solid or a gas? I got to find that line. That's this one right here. It gets less soluble, so that means it's a gas. And last question. 40 KCl, 80 degrees. Here's KCl, 80 degrees. I can have 50, I only have 40, it's unsaturated. All right, well, let me email questions if you have them. Otherwise, I'll see you on Friday, probably.